Good morning to all. My name is Suraj Maharana. I am studying in SUS Brahmapur. I representing you Transport Layer Security TLS. Contents: Basic of TLS, TLS Handshake Protocol, and Shipper Suite Negotiation and Authorization and Key Action. The TLS Handshake Protocol involves the following steps and receiving a secure session by using TLS and TLS record protocol. Basic of TLS. TLS stands for Transport Layer Security. It is an IETF standardization initiative whose goal is to come out with an internet standard version of SSL. IETF Internet Engineering Task Force. Transport Layer Security TLS is a protocol that ensures privacy between communicating application and their user on the internet. When a server and client communicate, TLS ensures that no third party may eavesdrop or tamper with any message. TLS is the successor to the secure sockets layer SSL, and the TSL protocol is based on Netscape SSL 3.0 protocol. However, TLS and SSL are not interpretable. The TLS protocol does contain a mechanism that allows TLS implementation to break down to SSL 3.0. The most recent browser versions support TLS, and TLS is composed of two layers: the TLS protocol, the TLS record protocol, and the TLS handshake protocol. And the TLS record protocol provides connection security with some encryption methods such as the data encryption, standard DES, symmetric key algorithm. The TLS record protocol can also be used without encryption, and the TLS handshake protocol allows the server and client to authenticate each other and to negotiate an encryption algorithm and cryptographic keys before data is exchanged. And TLS handshake protocol. The transport layer security TLS handshake protocol is responsible for the authorization and key action necessary to establish or resume secure sessions. When establishing a secure session, the handshake protocol manages the following: and shippers suite negotiation and authorization of the server and optionally the client, and session key information action and shipper suite negotiation. The client and server may contain and choose the slipper suite that will be used throughout their message action. Authorization and encryption communication. And authorization. In TLS, a server proves its identify to the client. The client might also need to provide its identify to the server PKI. The use of public-private key pairs is the basic of this authorization. The exact method used for authorization is determined by the shipper suite negotiated key exchange. The client and server exchange random numbers and a special number called the pre-master secret. These numbers are combined with additional data permitting client and server to create their shared secret called the master secret. The master secret is used client and server to generate the right MS secret, which is done by used for hashing, and the right key, which is the session key used for encryption. The TLS handshake protocol involves the following steps: the CLS, the client sends a client hello message to server along with the client's random value and supported spare suites. Second, the server seconds by sending a server hello message to the client along with the server's random value, and the server sends a certificate to the client for authorization and may request a certificate from the client. The server sends the server hello done message, and if the server has requested a certificate from the client sends it, and the client creates a random pre-master secret and encrypts it with the public key from server certificate, sending the encrypted pre-master secret to the server, and the server receives the pre-master secret. The server and client each generate the master secret and session keys based on the pre-master secret. The Slint sends change hyperspace notification to server to indicate the slides will start using the new season keys for hedging and encrypting message. Slide also sends slide finished a message, and server receives change slipper space and switch is record layer security state to symmetric institution using the season keys. Server sends server finished message to the slide and server and now exchange application data about the secure channel they have established. All message sent from Slane to server and from server to Slane encrypted using season key. Resuming a secure season by using TLS. The Slane sends Slane hello message using the ID of the season to be resumed, and the server checks its season cache for a matching season ID. If a match is found and the server is able to resume the season, it sends a server message with the season ID. And note, if a second season ID match is not found, the server generates a new season ID and the TLS and server perform a full handshake. And slide and server mock section change space message and send client finished and server finished message. Client and server can now resume application data exchange over the secure channel. TLS record protocol. The transport layer security TLS record protocol secures application data using the keys creating during the handshake. The record protocol is responsible for securing application data and verifying its integrity. And origin it manages the following: 1. Dividing outgoing message into manageable blocks and resembling incoming message. Second, compressing outing blocks and decompressing incoming blocks optional. Third, applying a message authorization code MAC to outgoing messages and verifying incoming messages using the MAC. Fourth, encrypting outgoing messages and decrypting incoming messages. When the record protocol and handshake protocols are completed, the outgoing encrypted data is passed down to the transmission control protocol, TCP, layer for transport. Thank you.